Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So, my dear students, let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Good evening, people. Good evening, and welcome back. Good evening, and welcome back. So, let me know quickly in the chats, people, if all of you can hear me, if I'm perfectly audible and visible to every one of you. All right, people. I know all of you were desperately waiting for this session. Well, this session was supposed to happen yesterday, but because I was not well yesterday, right? I did not take any session yesterday, either online or offline, nothing, right? So I had to reschedule it for today, and here we are with the top 50 concepts of chemistry, my dear students, right? So all those students who have no idea what this top 50 concepts, this concept is exactly all about, let me tell you, when it comes to your subject chemistry, almost there are some 50 to 60 topics, right, from which your majority of the NEET paper comprises of. Okay, and I will be taking 2 to 3 sessions in order to cover those 50 to 60 topics. Okay, and one thing I'm going to tell you, that you are going to find the questions directly or indirectly from these 3 sessions which I have scheduled for all of you. That is top 50 concepts, part 1, part 2, and part 3. So do watch them, because all the students who joined me before May 3rd, right, I took the similar sort of sessions from where almost 15 to 16 questions were directly asked, right? So I'm pretty much sure from these sessions which I'm going to start from today, right? Today is session number 1, tomorrow is session number 2, right? From these sessions, again, you'll find the questions directly, indirectly from your upcoming Re-NEET examination as well. Perfect. And guys, at the same time, one more thing, the handwritten PDF of this particular session I'll be sharing on my Telegram. If you are not the part of the Telegram channel yet, be the part of the Telegram channel as soon as possible. Well, let me give you the name of the Telegram channel. My dear students, the name of the Telegram channel is Wassim Bhat Chemistry Official. WASSIM BHAT Chemistry. Official is the name of the Telegram channel on which I shall be sharing the handwritten PDF of the today's session as well as the tomorrow's session. This is the Telegram channel, my dear. Okay. So are you all ready? Should we start? Okay, before starting, tell me which part of the country you guys are watching me from. I just want to know that first. Tell me which part of the country you guys are watching me from, quickly, in the chats. What is the duration of today's session? Duration of today's session will be 1.5 to 2 hours. 1.5 hours or maximum 2 hours. Quickly, people. I want to know which part of the country you guys are watching me from right now. Quickly in the chats. Okay. I can see students across the country have joined. That's great. Well, majority is from South India. Of course, that is evident. Tamil Nadu, Karnataka, Gujarat, Maharashtra, Andhra, Mumbai. Chhattisgarh, Lucknow, Dubai, Bihar, Telangana, Kerala, Rajasthan, Chhattisgarh. All right. Got it, guys. Got it. Okay. Quickly, some fire emojis in the chat so that we can start. that I'll get to know everything is perfectly fine. Yeah? Quickly in the chats, people. Quickly in the chats. Perfect, perfect, perfect. All right. Perfect, guys. So let's begin then. Let's start the session. And before starting the sessions, the ones who have not liked the session yet, liking the session is mandatory, guys. So you are supposed to like the session right now. Okay? Do smash the like so that you mark your attendance too. All right, people. So let's get going with the first concept, that is concept number 1. Concept number 1 from the first chapter of your chemistry. My dear students, the concept number 1, which is from the first chapter of your chemistry, that is something called as stoichiometry. That is something called as stoichiometry. Now I'm going to tell you what the stoichiometry exactly is all about. Now I'm going to tell you what the stoichiometry exactly is all about, and at the same time, what kind of the questions can be framed from stoichiometry. Understand, people, what exactly I'm going to do. For example, I have got a balanced chemical equation. Let's say the balanced chemical equation is something like this. 2 times A plus 2 times A, let me keep it simple, 2 times A gives 3 times B plus 5 times C. Let's assume this is a balanced chemical equation, my dear students. Okay? And this 2, 3, and 5, these are the stoichiometric coefficients of reactants and products. Let's assume that this is a balanced chemical equation, and this 2, 3, and 5, these are the stoichiometric coefficients of reactants and products. Now, my dear students, whenever you are supposed to deal with the questions of stoichiometry, what you have to do is, you just have to write one equation. The equation is something like this. You'll write number of moles of A divided by stoichiometric coefficient of A is equal to number of moles of B divided by stoichiometric coefficient of B is equal to number of moles of C divided by stoichiometric coefficient of C, that is 5. This is the kind of the equation which you have to make, and from this equation, any sort of question can be formed. Any sort of question can be made. Okay? For example, let's say you have got the reaction like this. N2 gas plus 3 times H2 gas. Let's say it gives 2 times NH3 gas. This is, for example, a general reaction that I'm taking into consideration. Now, what you have to do, you can just make an equation like this, and the equation format is going to be something like this. You write number of moles of N2 divided by stoichiometric coefficient of N2 is equal to number of moles of H2 divided by stoichiometric coefficient of H2 is equal to number of moles of NH3 divided by stoichiometric coefficient of NH3. Right? This is the equation which you have to make. And if you are able to make these equations, you can easily solve all the questions which are based on stoichiometry. For example, let me give you a few questions so that you can understand where do we use the concept. For example, this is one very common question. A very common question this. You'll understand what to do. The question is saying calculate the mass of O2 gas. Calculate the mass of O2 gas produced on heating 12.25 grams of KClO3. My dear students, the first thing which you all must be knowing, when KClO3 is heated, it gets converted into KCl, and with that, you get O2 gas as well. So first of all, this is the reaction, which everyone should remember. When KClO3 is heated, you get KCl, with KCl, you get O2 gas. Always remember, your first step will be always to balance the reaction. Now, if I ask you, is the reaction balanced? The reaction is not balanced yet. So let's try to balance this reaction. This becomes 2 times, this becomes 2 times, this becomes 3 times. First of all, you will be writing the reaction. Second, after writing the reaction, you will be balancing the reaction. Now, after balancing the reaction, whatever is the given quantity, convert the given quantity into moles. As you can see, you are given with mass of KClO3. Now, convert this mass of KClO3 into moles of KClO3. You can write number of moles of KClO3 will be equal to given mass of KClO3 in grams divided by molar mass of KClO3. And if you do not know, let me tell you, molar mass of KClO3 is 122.5 grams. This value comes out to be 0.1. Got it? So I wrote the reaction, I balanced the reaction, then I converted given quantity into number of moles. After converting given quantity into number of moles, my dear students, understand what the question is. Calculate the mass of O2. Calculate the mass of O2 produced on heating 12.25 grams of KClO3. So write the stoichiometric equation, which I showed you a few minutes back, like how to write that. So what you have to do, you'll write number of moles of KClO3 divided by stoichiometric coefficient of KClO3 is equal. You have got nothing to do with this right now. Talk about oxygen. It's going to be number of moles of O2 divided by stoichiometric coefficient of O2, right? So in this particular equation, let's calculate number of moles of O2. I'll say number of moles of O2 will be equal, take this 3 here, it becomes 3 by 2 times number of moles of KClO3. Now you tell me one thing, 3 by 2 I'm writing as such, number of moles of KClO3. How many moles of KClO3 do we have? 0.1. When you solve this, the value comes out to be 0.15. So my dear students, you got the moles of O2. But as per the question, are we supposed to calculate moles of O2 or mass of O2? We are supposed to calculate mass of O2, which will be equal to moles of O2 multiplied by molar mass of O2. When you solve this, the value comes out to be simply 4.8 grams. So you got to know 4.8 grams of O2 are produced. 4.8 grams of O2 are produced when we do the decomposition of 12.25 grams of KClO3. Let me know once in the chats if this is clear. Everyone in the chats, people. Let me know in the chats quickly. Let me know in the chats quickly. Everyone. Quickly in the chats. Understood? Yes? Perfect. Let me give you one more question. Look at this particular question, guys. Look at this particular question. Calculate the volume of carbon dioxide gas produced at STP by complete combustion of 570 grams of octane. First of all, I believe all of you would be knowing what is the formula for octane. Octane is C8H18. You are doing its combustion. Combustion means you are making it to react with oxygen. It will lead to the formation of carbon dioxide, and with carbon dioxide, you get water as well. With carbon dioxide, you get water as well. Now, what's the first thing which we do? We balance the reaction. We balance the reaction. Now, my dear students, when you balance the reaction, this will be 8, this will be 9, and this will be 25 by 2 times. When you balance this particular reaction. Okay. Now, after balancing the reaction, what are we supposed to do? We are supposed to convert the given quantity into moles. What is our given quantity? We are given with mass of octane. So, convert the mass into moles. So, moles of octane will be equal to given mass of octane in grams divided by molar mass of octane. When you calculate, that will be 114. The value comes out to be 5. Done? Now, calculate the volume of carbon dioxide. Calculate the volume of carbon dioxide produced by the complete combustion of 570 grams of octane. Perfect. Now, make the stoichiometric equation over here. So, you can write number of moles of octane divided by stoichiometric coefficient of octane, that's 1, is equal to number of moles of carbon dioxide divided by stoichiometric coefficient of carbon dioxide. So from this particular equation, can I calculate the moles of carbon dioxide? Absolutely. I can say moles of carbon dioxide will be equal to 8 into moles of octane. 8 multiplied by moles of octane. Right? So it's going to be 8 multiplied by moles of octane. Already we have calculated, that's 5. So 8 multiplied by 5 is 40. So you got the moles of carbon dioxide. But as per the question, are we supposed to calculate moles of carbon dioxide? No. We need to calculate volume of carbon dioxide. So I'll say volume of carbon dioxide will be equal to moles of carbon dioxide multiplied by 22.4 liters. This value after solving comes out to be how much? This will be 896 liters. So this is the volume of carbon dioxide which I was supposed to calculate as far as the question is concerned. So tell me once in the chats if this particular question is clear or not. Everyone, people. Everyone. Yes? Look at the third question, guys. Look at the third question. This is again one more type of the question which can be asked in your examination. The question is calculate the mass of H3PO4. Calculate the mass of H3PO4. Sir, how did we get 25 by 2? 25 by 2. If you do not know how do we get 25 by 2, remember, if you have got CXHY and you are making it react with O2, first of all, it leads to the formation of carbon dioxide and water. Now, if you want to write the reaction in balance form, this is X becomes the coefficient here, Y by 2 becomes the coefficient here, and the coefficient of O2 here will be X plus Y by 4. X plus Y by 4. Now, by the help of this, you balance the combustion reactions base. All right, moving ahead. Look at this particular question. Calculate the mass of H3PO4. Calculate the mass of H3PO4, which contains 0.25 moles of O. Which contains 0.25 moles of O. You tell me one thing, guys. If I talk about 1 mole H3PO4, if I talk about 1 mole H3PO4, can you tell me in 1 mole H3PO4, how many moles of O are there? I'll say there are 4 moles of O. This is something we already know. 1 mole of H3PO4 contains 4 moles of O. Now make the stoichiometric equation, which I told you a few minutes back. Just write one thing. Number of moles of H3PO4 divided by stoichiometric coefficient of H3PO4 is equal to number of moles of O divided by this 4 over here. Right? Perfect. What we have to calculate? From this equation, you can calculate the moles of H3PO4. That will be equal to number of moles of O, which are given in the question itself. That is 0.25 divided by 4. The value comes out to be 1 by 16. Right? So you got the moles of H3PO4. But as per the question, am I supposed to calculate moles of H3PO4? No. I want to calculate mass of H3PO4. So mass of H3PO4 will be equal to moles of H3PO4 multiplied by molar mass of H3PO4. That will be 98. When you solve this, the value comes out to be 6.125 grams. So I would say 6.125 grams of H3PO4 will be containing 0.25 moles of O. That is the something which I was supposed to calculate in the question. If I'm clear, let me know once in the chats. Quick. Yes? Perfect, people. Is it clear? Yes or no quickly in the chats? One more similar sort of question I'm giving you. Now you should be able to solve that on your own. For example, the question is like this. Calculate the moles of O in 196 grams of H2SO4. Calculate the moles of O in 196 grams of H2SO4. What is my first step always? My first step always is to convert the given quantity into moles. Now, given quantity is mass. So, convert mass of H2SO4 into moles of H2SO4. I would say moles of H2SO4 will be equal. Given mass of H2SO4 divided by molar mass of H2SO4. The value comes out to be 2. Right? I converted the given quantity into moles. Now, my dear students, after converting the given quantity to moles, now we know 1 mole of H3PO4, 1 mole of H2SO4. We know 1 mole of H2SO4. 1 mole of H2SO4 contains 4 moles of O. This is something we already know. Now make the stoichiometric equation and you are done. You'll write number of moles of H2SO4 divided by, here the value is 1, is equal to number of moles of O, here the value is 4. Perfect. Right? So my dear students, from this equation, you can calculate moles of O. Moles of O will be 4 times moles of H2SO4. 4 times moles of H2SO4. So it's going to be 4 multiplied by moles of H2SO4 already we have calculated. The value comes out to be 8. So you can say 8 moles of O are present in 196 grams of H2SO4. Tell me, people, if the question is asked from this particular type, will you be able to solve it? Quickly in the chats. Everyone. Quickly let me know in the chats. Did you understand? Did you understand, people? Yeah? Whosoever wants to do any sort of chatting and stuff in the chats, please go to some other channel. If I see anyone writing anything apart from the stuff which I'm teaching, I'm going to block you right there. Just understand. If you are new to the channel, if you do not know me, okay? All right? Chalo, let's move on. Let's move on, guys. Let me give you one more question. Let me give you one more question. And just tell me the answer of this in the chats quickly. The question is, calculate the mass of calcium carbonate required to produce 224 liters of carbon dioxide gas during its decomposition at STP. Give this question a try quickly and tell me its answer in the chats. Everyone. 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 Guys, the question is pretty simple. You are just supposed to follow the concept that I give you right now. What was the concept? First of all, write the reaction. Calcium carbonate, when we heat it up, you get calcium oxide, and with that, you get carbon dioxide. So it is your balanced chemical equation. It is your balanced chemical equation. Now, what do we have to do? Convert the given quantity into number of moles. If you look at your given quantity is volume, right? So convert volume into moles. So moles of carbon dioxide will be equal. Given volume in liters divided by 22.4 liters. The value comes out to be 10, right? These are the moles of carbon dioxide, right? Now, my dear students, the question says what mass of calcium carbonate is required to produce 224 liters of carbon dioxide. Now write the stoichiometric equation. The equation is simple. Number of moles of calcium carbonate divided by stoichiometric coefficient 1 is equal to number of moles of carbon dioxide divided by stoichiometric coefficient 1. Perfect. So number of moles of calcium carbonate comes out to be equal to number of moles of carbon dioxide, which we already have. That's equal to 10. So if you got the moles of carbon dioxide, you can get the mass of calcium carbonate as well. If you got the moles of calcium carbonate, you can get the mass of calcium carbonate as well. What exactly? It's going to be moles multiplied by molar mass of calcium carbonate. The value comes out to be how much? The value is going to be 1000 grams. This is something which you are supposed to calculate. Done and dusted, right? Perfect, guys. Perfect, people. Now, let's move on to the second concept, which can be asked from the same chapter. The concept is limiting reagent, right? I'll be just showing you, giving you the tricks of solving the questions. Nothing more, nothing less. Understand? Understand, people. First of all, what is the limiting reagent? How do we define the limiting reagent? I believe all of you must be familiar with the fact what limiting reagent is. Limiting reagent is that reactant. Limiting reagent is that reactant which gets completely consumed. Which gets completely consumed in the reaction. That reactant which gets completely consumed during the course of the reaction, you call that reactant as the limiting reagent. Now, people, understand what exactly I'm going to do. For example, imagine that you have got a reaction like this. 2 times A plus 3 times B, it gives 5 times C. Let's say you have got a reaction like that. Okay. Now, for example, at time t is equal to 0, let's say I'm starting with 10 moles of A, I'm starting with 10 moles of B. Since I wrote time t is equal to 0, so moles of C formed would be 0. Because time t is equal to 0 signifies that the reaction has not started yet. And if the reaction has not started, that means product formation has not taken place yet. That means product formation has not taken place yet. Okay. So at time t is equal to 0, we are starting with 10 moles of this, we are starting with 10 moles of this. Right now, product has not got formed, so 0 moles of C have got formed. Now, in the question, what kind of questions they will give you from limiting reagent? The first thing they'll ask you, identify the limiting reagent. Number 1, identify the limiting reagent. Number 2, they'll ask you the moles of C formed. The moles of C formed. This is the second question. The third question they'll ask you the moles of excessive reagent left. Excessive reagent left. These are the three things which they can ask. These are the three things which they can ask. Now, how do we deal with such kind of questions? My dear students, how do we first of all identify the limiting reagent? Simple method. Given moles divided by stoichiometric coefficient. Given moles divided by stoichiometric coefficient. See, 10 divided by 2 is 5. 10 divided by 3 is 3.33. Which one is the lesser value? 3.33. That reactant which gets the lesser value is always your limiting reagent. So B is my limiting reagent. B is my limiting reagent. Limiting reagent, I got to know that is B. Given moles divided by respective stoichiometric coefficient, that gives me the limiting reagent. Given moles divided by stoichiometric coefficient, the one that gets the lesser value, that's my limiting reagent. So B is my limiting reagent. Now B is going to decide everything. B is going to decide everything in this particular reaction, people. Since B is the limiting reagent is the one that gets completely consumed. So after some time, what you will observe? You'll observe there'll be 0 moles of B left. When the reaction starts, after some time, you'll observe there'll be 0 moles of B left. Because B is the limiting reagent. It gets 100% consumed in the reaction. So after some time, you'll find 0 moles of B. When B got completely consumed, at that point of time, you'll find some moles of C and you'll find some moles of A as well, which will be still left as such. Some moles of A would be left because if B is the limiting reagent, then A is the excessive reagent, right? That means out of 10 moles of A, some moles of A would be still left in the container. Similarly, some moles of C have got formed. Now, how do we get the moles of C formed? How do we get the moles of A left? For that, one simple thing you have to calculate. You have to see. What is that? For example, I have to calculate moles of C formed. I have to calculate moles of C formed. What you'll write? You'll first of all write stoichiometric coefficient of C divided by stoichiometric coefficient of limiting reagent. That is your B. Stoichiometric coefficient of C divided by stoichiometric coefficient of limiting reagent multiplied by number of moles of limiting reagent. Number of moles of limiting reagent. Pretty much simple. What is the stoichiometric coefficient of C? That's 5. Divided by. What is the stoichiometric coefficient of B? That is 3. Multiplied by. Number of moles of B. Number of moles of B were 10. So the answer is 50 divided by 3. So you got to know 50 by 3 moles of B have got formed at the end of the reaction. Simple. Okay. Now, if you have to check, out of 10 moles of excessive reagent, out of 10 moles of A, how many moles of A have reacted? Number of moles of A that have reacted. Again, that is something which will be decided by the limiting reagent. How exactly? Number of moles of A reacted will be equal to stoichiometric coefficient of A divided by stoichiometric coefficient of limiting reagent, that's B, multiplied by number of moles of limiting reagent. Pretty much simple. Now tell me, what is the stoichiometric coefficient of A? That is 2. Divided by, what is the stoichiometric coefficient of limiting reagent? That is 3. Multiplied by moles of limiting reagent, that's 10. So the value is 20 by 3. So these are the moles of A which have reacted. These are the moles of A which have reacted. How many moles of A I took? I took 10 moles. Out of 10 moles, how many have reacted? 20 by 3 have reacted. So how many moles of A will be left? 10, which I took, minus how many have reacted? 20 by 3. These are the moles of A that would be still left in the container when the reaction would have stopped. So these sort of questions are, my dear students, asked frequently. Okay? Perfect. Perfect. Someone is saying, asking someone, are you done with your dinner? How are you? He's good. He's good. What do you want now? You want to be blocked? And you are blocked. Thank you so much for joining in. Online friends, yeah? Yes, I'm sweating a lot because I'm not well. I told you yesterday, right? Perfect, guys. I believe this particular concept is clear. Let's try to move on a few more things. Okay? Let's try to move on a few more things. Let's say this is the question. Without solving, looking at the question, tell me the answer. Tell me the answer, people. Tell me the answer of this particular question quick. Quickly, people. The question is saying 3 moles of NaOH. So we are starting with 3 moles of NaOH. We have got 4 moles of H2SO4 as well. We have got 4 moles of H2SO4 as well. Initially at time t is equal to 0. So this would be 0, this would be 0. Now we have just have to identify the limiting reagent. How do we exactly identify the limiting reagent? Given moles divided by respective stoichiometric coefficient. So 3 divided by 2 is equal to 1.5. Similarly, 4 divided by 1 is equal to 4. Which one is getting the lesser value? This is the lesser value. The one that got the lesser value is the limiting reagent. NaOH is my limiting reagent here. Simple. What do you think will be the answer of this question? On starting with 2 moles each of reactants, how many moles of B2H6 have formed? Again, a similar sort of question. The reaction is 6 times LiH plus 8 times BF3. What does it give me? It gives me 6 times LiBF4. 6 times LiBF4 plus B2H6. This is my reaction. Now, initially we are starting with 2 moles each of reactants. 2 moles of this, 2 moles of this. This would be 0, this would be 0. Now, first thing, which one is the limiting reagent? Tell me. Which one is the limiting reagent? Which one is the limiting reagent? Quickly. Simple. Divide the given moles by their respective stoichiometric coefficients. 2 divided by 6. Similarly, 2 divided by 8. Which is the lesser value? This is the lesser value. 2 by 8 is less. So this is my limiting reagent. So this BF3 is going to decide everything. What do I have to calculate? Moles of B2H6 formed. So number of moles of B2H6 formed will be equal. It will be equal to stoichiometric coefficient of B2H6. Stoichiometric coefficient of B2H6 divided by stoichiometric coefficient of the limiting reagent, that is BF3. That is BF3 limiting reagent multiplied by number of moles of BF3. As I told you a few minutes back. What is the stoichiometric coefficient of B2H6? That's 1. That's 1. Divided by. What is the stoichiometric coefficient of BF3? That's 8. Multiplied by. How many moles of BF3 we have? That's 2. So the value is 2 by 8. That means 1 by 4. So these are the moles of B2H6 which you were supposed to calculate. I believe I'm clear with this. Done? Done, people? Perfect. Okay. Can you give me the answer of this question quick? Like very, very, very quick. Give me the answer of this question very quick, people. Quickly, people, everyone. Similar sort of question. On starting with 10 moles each of reactants. On starting with 10 moles each of reactants. Calculate the moles of barium phosphate formed. Simple. Which one is the limiting reagent? 10 by 3 is 3.33. 10 by 2 is 5. So this value is getting lesser. Limiting reagent. Right? Moles of barium phosphate. Moles of Ba3PO4 whole twice formed is equal. Stoichiometric coefficient of barium phosphate divided by stoichiometric coefficient of the limiting reagent multiplied by moles of limiting reagent. So tell me, what is the stoichiometric coefficient of barium phosphate? That's 1 divided by what is the stoichiometric coefficient of limiting reagent? That's 3 multiplied by how many moles of limiting reagent do you see? That's 10. The value is nothing but 3.33. So 3.33 moles of barium phosphate have got formed. Pretty much simple. Right? I believe I'm clear with this. Okay? I believe I'm clear with this. Perfect, guys. Concept number 3. Empirical and molecular formula. Frequently asked question. Empirical and molecular formula. So what is this empirical and molecular formula, people? Pretty much simple again. Understand. For example, if I talk about glucose. One of the formulas of glucose that I know, that is C6H12O6. Right? So in glucose, I would say there are three elements: carbon, hydrogen, oxygen. What is the atomic ratio of these elements? The atomic ratio is 6:12:6. The atomic ratio is 6:12:6. Now tell me one thing. Can I further simplify this ratio? Absolutely. It can be 1:2:1. So how many ratios do you see here? There are two ratios which I have. This is something which I call as the simplest whole number ratio. This is something which you call as the actual ratio. There are two ratios which we have. One is simplest whole number ratio, one is the actual ratio. As per the actual ratio, the formula is C6H12O6. As per the simplest ratio, the formula should be C1H2O1. As per the actual ratio, the formula should be C6H12O6. And as per the simplest ratio, the formula should be C1H2O1. My dear students, this particular formula that gives you the simplest whole number ratio. You call this formula as the empirical form. And this particular formula which gives you the actual ratio, you call this as the molecular formula. So there are two things. One is molecular formula, one is empirical formula, right? Molecular formula gives you the actual ratio between the atoms. Empirical formula gives you the simplest ratio between the atoms. Okay? Now, one more thing, people. One more thing. Remember, with the help of molecular formula, we can calculate molecular mass. With the help of empirical formula, you can calculate empirical mass. With the help of molecular formula, you can calculate molecular mass of the substance. With the help of empirical formula, you can calculate empirical mass of the substance. How exactly? Molecular formula would be equal 12 into 6 plus 1 into 12 plus 16 into 6. That would be 180 U. Similarly, empirical mass 12 into 1 plus 1 into 2 plus 16 into 1. That comes out to equal to 30 U. So you got molecular mass, you got empirical mass. After this, my dear students, there's a number which I denote with X. What is X? X is the ratio of molecular mass and empirical mass of the substance. X is the ratio of molecular mass and empirical mass of the substance. And do remember one more thing. Molecular formula is nothing but, it is empirical formula multiplied by X. Molecular formula is nothing but empirical formula multiplied by X. Also remember, molecular mass is equal to 2 times the vapor density. These are some results which will be used in the questions. Molecular mass is equal to 2 times the vapor density. Okay. Now people, let's understand what do we do. Let's understand what do we do and how do we deal with such kind of the question. Understand properly. My dear students, here I'm going to write a question. This is the question. A pretty simple question. Calculate the empirical formula of the compound that contains 26.6% potassium, 35.4% chromium, and 38.1% oxygen. Right? This is the question. This is the question. This is the question. My dear students, try to understand. Try to understand. The compound that is given to us, in that compound, there are 3 elements given. We have got a compound that contains few elements. The first element is potassium, second is chromium, third one is oxygen. We have got some compound that contains 3 elements. Potassium, chromium, oxygen. Well, you should know what is the atomic mass of potassium? 39. Atomic mass of chromium, that is 52. Atomic mass of oxygen, that's 60. Remember in the question, you can be given with 3 things. Remember in the question, you'll be given with 3 things. Either you'll be given with the mass percentage of the elements, or you'll be given with the mass ratio of the elements, or you will be given with directly the masses of the elements in grams. Either you'll be given with the mass percentage of the elements, or you'll be given with the mass ratio of the elements, or you'll be directly given with the masses of these elements. In this particular question, we are given with the mass percentage of potassium, chromium, oxygen. What is the mass percentage of potassium? That is 26.6%. What is the mass percentage of chromium? That is how much? 35.4%. And what is the mass percentage of oxygen? That's given to me as 38.1%. So these are the values that are given to me. My first step always is to get the atomic ratio. How do we get the atomic ratio? How do we get the atomic ratio? Whatever things are given to us, divide all these things by their respective atomic weights. Divide all these things by their respective atomic weights. So 26.6 divided by 39. Similarly, 35.4 divided by 52. 38.1 divided by 16. When you solve this, this particular value will come out to be 0.68. This particular value will again be 0.68. This particular value will be 2.38. Okay. Now tell me one thing. Which one is the least number among all? The least number among all is 0.68. Now divide all these numbers by the least number. What do we get? We get the least atomic ratio. How exactly? Divide all these numbers by the least number. Least number is 0.68. So 0.68 divided by 0.68. Similarly, this 0.68 divided by least number is 0.68. This number is 2.38 divided by least number is 0.68. My dear students, when you calculate, this value comes out to be 1. This is 1. This is 3.5. This is 3.5. Is that the whole number ratio? 1 is to 1 is to 3.5. It is not the whole number ratio. 1 is to 1 is to 3.5. It is not the whole number ratio. So convert it into the whole number ratio. Multiplied by 2 with this 2 with this 2. This becomes 2, this becomes 2, this becomes 7. So 2 is to 2 is to 7. 2 is to 6, 2 is to 7 is the simplest whole number ratio. So as per that, the empirical formula comes out to be what? Empirical formula will be K2 CR2 O7. It's going to be K2 CR2 O7. This is the empirical formula of the compound which you were supposed to calculate. Am I clear with this? Am I clear with this, people? Everyone in the chats? Everyone in the chats, my dear students? Everyone? Yeah? Quickly. Anil, those notes are sufficient. No need to write the notes again. If you have already written the notes, so bounce back. Okay, let's try to move on to one more question. For example, this is the question. Look at this particular question. Look at this particular question. The question is a compound of nitrogen and oxygen. So you have got a compound that contains nitrogen and oxygen, right? As far as the question, their mass ratio is given. 7 is to 16. The mass ratio is. What is my first step always? To get the atomic ratio. How do we get the atomic ratio? Whatever things are given, divide them by the respect to atomic weights. Divide by them by the respect to atomic weights. So 7 divided by 14 is 0.5. 16 divided by 16. Now, which one is the smaller number? 0.5. So divide both of them by the smallest number. What do you get? You get the least atomic ratio. 0.5 by 0.5 is 1. 1 divided by 0.5 is 2. So the least atomic ratio is 1 is to 2. So with that, we got the empirical formula. What is the empirical formula? Empirical formula will be N1O2. It's going to be N1O2. If the empirical formula is N1O2, what would be the empirical mass? Empirical mass would be 14 into 1 plus 16 into 2. The value comes out to be 46. 46 AMU or 46U. This is the empirical mass. Okay. Now, vapor density is given as 46. So molecular mass will be equal to 2 times the vapor density. The value comes out to be 92. Okay. Now, get the X value. X is always equal to molecular mass divided by empirical mass. Molecular mass divided by empirical mass. So 92 divided by 46, the value is 2. If you got X, you can say molecular formula is equal to empirical formula multiplied by X. What is empirical formula? That was N1O2. What is the value of X? That is 2. The value comes out to be N2O4. So my dear students, this is the molecular formula of the compound which I was supposed to calculate. Am I clear? Everyone? Am I clear? Am I clear, people? Everyone in the chats? Is this particular concept clear? Everyone, quick. These sort of questions are asked in your exam. These sort of concepts are asked in the. Sir, what if vapor density is not given? Vapor density would be given in the question. If the vapor density is not given, then directly molecular mass will be given. Okay. Now, there is one more concept, guys, which can be asked. What is that? That is empirical molecular formula from combustion. Empirical molecular formula from combustion. Now, see what kind of question can be framed from this particular topic and how do we deal with this. One thing which you have to remember. For example, you have got an organic compound like this, CXHY. This is a hydrocarbon. It's a hydrocarbon. Okay? This is a hydrocarbon. Now you are doing the complete combustion of this hydrocarbon. You are doing the complete combustion of this hydrocarbon. Okay? Now when you do the combustion of hydrocarbon, what do we get? We get carbon dioxide and you get water. You get carbon dioxide and you get water. Okay? Now guys, what you have to remember? Just one thing. Just give me a second. I think there is electricity cut. Just give me a second, guys. Okay, I think this lighting will be enough for some time. There is some electricity cut, I think. Is the screen visible to you? Is the screen visible to you? Yes or no? Is the screen visible to you? Yes or no in the chats? Okay, I think the electricity will come in 2 minutes. Let's continue till then. See guys, whenever you see a hydrocarbon undergoing combustion leading to the formation of carbon dioxide and water, just remember one statement. Just remember one statement. One just statement. Remember, the mass of carbon in CXHY, the mass of carbon in this hydrocarbon will be equal to the mass of carbon in carbon dioxide. The mass of carbon in CXHY will be equal to the mass of carbon in carbon dioxide. This is the first thing which you have to write. The second thing, my dear students, mass of hydrogen in CXHY, mass of hydrogen in CXHY will be equal. Mass of hydrogen in CXHY will be equal to the mass of hydrogen in water. The mass of hydrogen in water. These are the two statements which you have to write. That's all. And you can easily solve the questions. You can easily solve the question. You can easily solve the question. Look at the question carefully. I mean, look at this particular thing carefully. I wrote, this is the hydrocarbon. You are doing its combustion. It gives carbon dioxide and water. Remember, the mass of carbon in hydrocarbon is always equal to the mass of carbon in carbon dioxide. Similarly, mass of hydrogen in hydrocarbon is equal to the mass of hydrogen in water. The mass of hydrogen in water. Now, guys, now try to understand. Now try to understand. For example, if you look at this particular question, read the question carefully. These sort of questions are again asked in the exam. My dear students, as far as the question is concerned, you have got 25 grams of unknown hydrocarbon. 25 grams of unknown hydrocarbon on complete combustion. On complete combustion. It gives, first of all, what? It gives carbon dioxide. With carbon dioxide, we get water. 25 grams of unknown hydrocarbon is undergoing complete combustion, is producing 88 grams of carbon dioxide and also producing 9 grams of water. When 25 grams of hydrocarbon undergoes complete combustion, it leads to the formation of 88 grams of carbon dioxide. With that, you get 9 grams of water. Now in the question, they are asking you, what is the mass of carbon and what is the mass of hydrogen in this hydrocarbon? Okay. How do we deal with such kind of a question? Understand, people. Understand. If you talk about this particular carbon dioxide here, I'm going to write a general information about carbon dioxide. General information about carbon dioxide. Can I say 44 grams of carbon dioxide, which is the molar mass of carbon dioxide? Can I say 44 grams of carbon dioxide contains 12 grams of carbon? This is the general information, which I believe every one of you would be already knowing. Okay. 44 grams of carbon dioxide contains 12 grams of carbon. Now tell me one thing. If 44 grams of carbon dioxide contains 12 grams of carbon, can I say 1 gram of carbon dioxide will contain 12 divided by 44 grams of carbon? Absolutely. So I can say 88 grams of carbon dioxide. 88 grams of carbon dioxide will be containing 12 divided by 44 multiplied by 88. The value comes out to be 24 grams of carbon. The value comes out to be 24 grams of carbon. So what you got to know? My dear students, you got to know one thing, that 88 grams of carbon dioxide, 88 grams of carbon dioxide contains 24 grams of carbon. 88 grams of carbon dioxide contains 24 grams of carbon. And I told you, the mass of carbon in carbon dioxide is equal to the mass of carbon in hydrocarbon. So this hydrocarbon contains 24 grams of carbon. Now, what is the mass of the entire hydrocarbon? 25 grams. Out of 25 grams of hydrocarbon, there are 24 grams of carbon. That means 1 gram will be the mass of hydrogen. Okay, these were the two things which you were supposed to calculate. Am I clear with this? Everyone in the chats. Am I clear with this, people? Everyone in the chats. Quick. Quickly, everyone in the chats. The next concept will be related to Bohr's model. The next concept will be related to what? The next concept will be related to Bohr's model. My dear students, in Bohr's model, you will be getting the first question. What is the first question? That is based on radius of nth Bohr's orbit. Radius of nth Bohr's orbit. Radius of nth Bohr's orbit, which we represent with Rn. And what is the formula? Let me tell you, the radius of nth Bohr's orbit is nothing but, that's R naught n square divided by z. R naught n square divided by z. And let me tell you, this R naught is nothing but, it is 0.529 angstrom. 0.529 angstrom. What is n? N is the shell number in which the electron is revolving. N is the shell number in which the electron is revolving. Z is the atomic number of the atom which we are talking about. Okay, number one. Number two, there is one more result. R1 divided by R2 will be equal to N1 square divided by N2 square multiplied by Z2 divided by Z1. This is one more result which you are supposed to remember. Whenever you are supposed to compare the radii of two orbits, this is the result which you'll be remembering. Okay, this is the result which you'll be remembering. Perfect. How do we use this result in the questions? That's something I'll tell you in some time. But first of all, remember these two results which I gave you over here. Okay. Now, my dear students, the second result from which the questions will be asked, what is that? That is the velocity of the electron. Velocity of the electron in the nth Bohr's orbit. Velocity of electron in the nth Bohr's orbit, which I represent with Vn. So let me tell you, velocity of the electron in the nth Bohr's orbit is equal to V naught Z divided by N. Right? What is V naught? V naught value is equal to 2.18 into 10 raised power 6 meter per second. Okay? Am I clear with this? And at the same time, if you have to compare the velocities of two electrons, you will be writing V1 by V2 is equal to Z1 divided by Z2 multiplied by N2 divided by N1. And remember these two results as well. Similarly, my dear students, the third question that will be asked from the time period. That will be asked from the time period of the electron in the nth Bohr's orbit. Time period of the electron in the nth Bohr's orbit. That is nothing but, that is T naught n cube upon z square. T naught n cube upon z square. That is the formula. This is the formula by means of which we can calculate what? We can calculate the time period of the electron in the nth Bohr's orbit. Right? 1.5 into 10 raised power minus 16 seconds is the value of T naught. Now, how do I compare the time periods of electrons in two different orbits? I can say T1 divided by T2 is equal to, this will be N1 cube divided by N2 cube multiplied by Z2 square divided by Z1 square. This is how you compare the radii of, this is how you compare the time period of the electrons moving in two different orbits. I'll show its application in a while, right? Now, the fourth thing, my dear students, which is asked, what is that? The fourth thing will be total energy. Total energy of the electron. Total energy of the electron in the nth Bohr's orbit. En is equal. Total energy of the electron in the nth Bohr's orbit is equal minus 13.6 Z square divided by N square electron volt. Now they can ask you about the kinetic energy possessed by the electron in the nth Bohr's orbit. That will be equal to plus 13.6 Z square divided by n square electron. They can ask you about one more thing. Potential energy possessed by the electron in the nth Bohr's orbit. That is minus 27.2 Z square divided by n square electron volt. These are some results which are related to total energy, kinetic energy, and potential energy possessed by the electron moving in the nth Bohr's orbit. Okay? Perfect. You first of all have to remember these results which I mentioned over here. You have to remember these results which I clearly mentioned. Now, my dear students, tell me what do you think will be the answer of this question. Again, a common question, and you can expect these sort of questions. Quickly, people. Quickly, let me know in the chats. Let me know in the chats, people. Understand. Calculate the radius ratio of second orbit of He positive. He positive and third orbit of Be tri positive. Okay. Now, first of all, what is the atomic number of helium? Hydrogen, helium. Atomic number 2. Lithium, beryllium. Atomic number 4. Right? Now, they are asking about the second orbit of helium. So, second orbit of helium means the orbit number here is 2. And here, the orbit number is how much? Orbit number is 3. Perfect. Let the radius here is R1. Let the radius here is R2. What we have to calculate? The radius ratio. We have to calculate the value of R1 by R2. R1 by R2 is nothing but N1 square divided by N2 square multiplied by Z2 divided by Z1. What is N1 ka square? N1 ka square, 2 ka square is 4 divided by N2 square. N2 square, 3 ka square is 9. Z2 is 4 divided by Z1. That's 2. The value comes out to be 16 by 18. That means 8 is to 9. So this is the radius ratio which you are supposed to calculate. Is that clear, guys? Is it clear? Is it clear? Everyone in the chats? Is it clear? I believe yes. If this is clear, tell me the answer of this particular question as well. Quickly in the chats. Quickly in the chats. Quickly in the chats. Quickly in the chats. This is again a very common question. I mean, you can get the questions in this format. That's my point of showing these sort of patterns. Quick. See, guys, if you look at this particular question, understand properly. If the velocity of electron in the first orbit of hydrogen atom, this hydrogen atom, and here I'm writing Li positive. First of all, atomic number of hydrogen is 1. Atomic number of lithium, hydrogen, helium, lithium, that is 3, right? Orbit number of hydrogen is given to me as 1. Orbit number of Li positive is given to us as 3, right? Velocity of the electron in the hydrogen atom is given to us as V. What do we have to calculate? We need to calculate the V2 value. V1 is given. We need to calculate V2. Now, what is the formula which I'll be using? Few minutes back, I gave you the formula. V1 divided by V2 is equal. What was the formula? It was Z1 divided by Z2 multiplied by N2 divided by N1. This was the formula that I gave you. Because Vn is equal to V naught Z by N, right? From that formula, we derived this. Now, what is V1 value? V1 value is V. V2 needs to be calculated. Z1 is 1. Z2 is 3. N2 is 3. N1 is 1. So 3 got cancelled. The value is 1:1. So I can say V is equal to V2. I can say V2 is equal to V. V2 is equal to V. This is something which you are supposed to calculate. I believe, again, this sort of a question is clear to everyone, right? Now, my dear students, there is one more concept from which the question is frequently asked. What is that? That's your hydrogen spectrum. Hydrogen spectrum. Hydrogen spectrum. Yeah? Let's get to know what this hydrogen spectrum exactly is all about. Let's try to understand every single thing in detail. See, guys, this is something important, and I would want you guys to understand this properly. My dear students, for example, there are few lines which I'm going to draw first. Then I'll make you understand why am I drawing these lines and what kind of the questions can be framed from these sort of lines over here. First of all, let's say this is equal to n is equal to 1 for hydrogen. This is nothing but n is equal to 2 for hydrogen. This is n is equal to 3. This is n is equal to 4. This is n is equal to 5. This is n is equal to 6. And this n is equal to infinite. Right? Which atom am I talking about? I'm talking about hydrogen atom right now. I'm talking about hydrogen atom right now. Now, my dear students, n is equal to 1. N is equal to 1. This is called as ground state of hydrogen. This is called as ground state of hydrogen. N is equal to 2. This is called as first excited state of hydrogen. First excited state of hydrogen. Similarly, n is equal to 3. This is something I call as second excited state of hydrogen. Similarly, third excited state of hydrogen, and so on. And so on. Now, I believe one thing which all of you would be already knowing. What is that one thing? You know, when the electron makes a transition from lower energy state to higher energy state, when the electron makes a transition from lower energy state to higher energy state, at higher energy state, the electron is unstable. At higher energy state, the electron is unstable. Therefore, the electron jumps back. And my dear students, when the electron makes a transition from higher energy state to lower energy state, when the electron makes a transition from higher energy state to lower energy state, it emits energy in the form of radiation. It emits energy in the form of radiation. And remember, when the electron makes a transition from higher energy state to shell number 1. When the electron makes a transition from higher energy state to shell number 1, like this. Higher energy state to shell number 1, like this. Higher energy state to shell number 1, like this. Higher energy state to shell number 1, like this. Higher energy state to shell number 1, again. Higher energy state to shell number 1. What do we get? We get a series of radiation. And that series is something which you call as the Lyman series. And similarly, when the electron makes a transition from higher energy state to shell number 2, higher to shell number 2, higher to shell number 2, higher energy state to shell number 2, higher energy state to shell number 2, higher energy state to shell number 2, what do we get? We get a series of radiations. We call this particular series as the Balmer series. Similarly, when the electron makes a transition from higher energy state to shell number 3, higher energy state to shell number 3, like this. Higher energy state to shell number 3, higher energy state to shell number 3. We get a series of radiation. Lyman-Balmer, this is called as Paschen series. Similarly, higher energy state to shell number 4, higher energy state to shell number 4, higher energy state to shell number 4. We get a series of radiation. We call this as bracket series. And similarly, higher energy state to shell number 5, higher energy state to shell number 5. We get a series of radiations called as Fund series. This is something which I believe every one of you would be already knowing. Now, my dear students, the first question that's asked. Lyman series falls in which region? Lyman series falls in which region? Ultraviolet, visible, infrared. Lyman series falls in which series? Let me tell you, this Lyman series it falls in which region? It falls in ultraviolet region. UV, ultraviolet region, right? Balmer falls in visible region, or you can say visible spectrum. Paschen falls in infrared. Bracket again falls in infrared. Fund again falls in infrared. This is the first question that will be asked, memory based. The second question, people, the second point, if you look at the Lyman series, here the electron is making a transition from 2 to 1. The electron is making a transition from 2 to 1, right? This particular line I'll be calling as the first line of Lyman series. Or you can call it as H alpha line of Lyman series. This is something I call as 3 to 1, second line of Lyman series, or H beta line, third line of Lyman series, fourth line of Lyman series, and so on. Similarly, this is the first line of Balmer series, second line of Balmer, third line of Balmer. Or you can say H alpha line, H beta line, H gamma line. First line of Paschen, second line of Paschen, third line of Paschen, H alpha line of Paschen, H beta line of Paschen, H gamma line of Paschen, and so on. So you should know the naming of these lines first of all. Okay? Yeah? All right? Am I clear, people? Who is this Arun Kumar? You blocked her account, yes or bro? Have you come here for this blocking, unblocking, chit chatting, nonsense stuff? You are blocked too, by the way. Go and find her somewhere else. I play for PC. And you're right. Used to play for that. Was the founder of that particular. Anyways, move ahead. I believe this particular thing is like very, very, very clear to everyone. Yeah. Sir, do roasting loudly. Yeah, let the people give me the full tosses. Yeah, I'll throw them out of the stadium. Let them give me the full tosses. Sir, we are discussing about studies. Yeah, I saw like it was a great, you know. This will be the question asked in your Re-NEET examination. Was she blocked or not? Yes, no, true or false? Yeah. This is going to be very, very, very important. I believe this particular step is clear. Okay. Now, my dear students, there are a few more things. There are a few more things which you need to know. Okay. What is that? What is that? There is a thing called as Rydberg's formula. There is a thing called as Rydberg's formula. So let me first of all show what that Rydberg's formula is all about. And after that, I'll tell you when that particular formula is used. When that particular formula is used. Just give me a second. Just give me a second. Just give me a second. Okay, let's have a look on something called as Rydberg's formula. My dear students, this Rydberg's formula looks like this. 1 divided by lambda is equal or z square 1 upon n1 square minus 1 upon n2. This particular formula is called as your Rydberg's formula. 1 by lambda is equal to r z square 1 upon n1 square minus 1 upon n2. Now, first of all, what is n1, what is n2? Let me tell you, n1 is called as the lower energy state. n2 is called as the higher energy state. Lower energy state, higher energy state. Now, when the electron makes a transition from higher energy state to lower energy state, it emits energy in the form of radiation. It emits energy in the form of radiation. And that radiation has got some wavelength. That radiation has got some wavelength. How do we calculate that wavelength? With the help of this particular result. With the help of this particular result. 1 by lambda is equal 1 by lambda is equal to r z square 1 upon n1 square minus 1 upon n2. Now, over here, you have to remember one thing. What is that? Remember 1 by r value. 1 by r is equal to 911.5 angstrom. Remember this particular thing as well. 1 by Rydberg's constant r is equal to 911.5 angstrom. Now, my dear students, try to understand a few more things. For example, there is a question. There is a question. There is a question. What is the question exactly? Calculate, or let me not write the full question. Let me write some important stuff. See, there is a term called as series limit. There is a term called as series limit. Series limit, it is also called as the shortest wavelength. Series limit is also called as the shortest wavelength. Let's say I need to calculate the series limit in case of Lyman. I need to calculate series limit in case of Lyman. They'll ask you the question. Calculate the series limit in case of Lyman. Okay. Series limit is what? Shortest wavelength. Tell me one thing. Do you know this result? Delta E is inversely proportional to lambda. More the energy gap, lesser the wavelength emitted or absorbed. More the energy gap, lesser the wavelength emitted or absorbed. Do you know that? Yes. Now, my dear students, what do we have to calculate? We have to calculate series limit. In what? In Lyman. Series limit means shortest wavelength. Shortest wavelength. Tell me, when can the wavelength be shortest? Wavelength can be shortest if delta E is maximum. If delta E is maximum, if energy gap is maximum. In case of Lyman series, when will be the energy gap maximum? In case of Lyman series, the energy gap will be maximum when the electron makes a transition from infinity to 1. From infinity to 1. This has to be the transition. Then only energy gap will be the maximum in Lyman. And if energy gap is maximum, lambda automatically will be minimum. Okay. Now, the lower energy state we represent with N1. Higher energy state we represent with N2. Now we can use the formula. Formula is 1 divided by lambda is equal to R. Z square. Z for hydrogen is 1. 1 upon N1 square minus 1 upon N2 square. Infinity ka square is infinity only, right? So 1 by infinity is 0. So I will say 1 by lambda is equal to R. Or you can say lambda is equal to 1 by R. And 1 by R value is nothing but 911.5 angstrom. So this is the wavelength emitted. I mean, this is the shortest wavelength emitted in case of Lyman series. Now they can ask you one more question. Calculate the longest wavelength. Calculate the longest wavelength in Lyman. Calculate the longest wavelength, lambda maximum. In what? In Lyman. You should be again able to solve this question. Tell me, in case of Lyman, when can be lambda maximum? Lambda can be maximum when energy gap is minimum. Now, in your Lyman series, you have to calculate lambda maximum. Lambda will be maximum when energy gap is minimum. In case of Lyman, when is the energy gap minimum? When the electron makes a transition from 2 to 1. Energy gap is minimum. 3 to 1 is more. 4 to 1 is even more. So, I'll be taking the transition from 2 to 1 here. The transition will be from 2 to 1. The lower energy state is something I represent with N1. Higher energy state is something I represent with N2. Now use the formula. 1 by lambda is equal to R. Z square. Z value is 1. 1 upon N1 ka square is 1. Minus 1 upon N2 ka square. 2 ka square is 4. So it's going to be 4 minus 1. That's 3 by 4. 3 by 4 multiplied by R. So if you take the reciprocal, so you can say lambda is equal to 4 by 3 multiplied by 1 by R. And it's going to be 4 by 3. 1 by R value is nothing but 911.5. And this is going to be the final answer. I believe these sort of questions you can do from now onwards easily. Yes? If I'm clear, let me know once in the chats, people. If I'm clear, let me know once in the chats. Okay? So these sort of things are asked in your examination. Now, one more important topic, my dear students. What is that? Calculation of spectral lines. For example, the question is, the electron is making a transition from 10 to 1. The electron is making a transition from 10 to 1. How many total number of spectral lines can be observed? How many total number of spectral lines can be observed? Sir, I'm not getting PDF in chemistry and physics also. Bro, check my Telegram, Wassim Bhat Chemistry Official. I keep on sharing all my PDFs there, right? Please do not spam here. Yeah? So, my dear students, maximum number of spectral lines. There is a formula to calculate maximum number of spectral lines, and the formula is N2 minus N1 multiplied by N2 minus N1 plus 1 divided by 2. This is the formula with the help of which we calculate the maximum spectral lines. Now, for example, understand. For example, the question is like this. Electron is making a transition from 5 to 1. Electron is making a transition from 5 to 1. How many maximum spectral lines can be observed? How many maximum spectral lines can be observed? I'll say maximum spectral lines. Maximum spectral lines which can be observed will be equal. The formula is already in front of you. Now you know the lower energy state is N1, higher energy state is N2. So it's going to be N2 minus N1, N2 minus N1. So 5 minus 1 multiplied by N2 minus N1, 5 minus 1 plus 1 divided by 2. So this value is going to be 5, 5 4s are 20, 20 by 10 is 20 by 2 is 10. So in total, there will be 10 spectral lines observed. In total, there will be 10 spectral lines observed. Now, out of these 10 spectral lines, how many will fall into Lyman? How many will fall into Balmer? How many fall into Paschen? There's a formula for that as well. Remember, the number of spectral lines falling in a particular series, it's always equal. N2 minus ground state of that series. N2 minus ground state of that series. Remember this particular result as well. Then there are total 10 spectral lines observed. Out of 10 spectral lines, there will be some spectral lines which will fall into Lyman, some will fall into Balmer, some will fall into Pasteur. So how many will fall into Lyman? Is equal to N2, that is the higher energy state. N2 is 5 minus ground state of Lyman. Ground state of Lyman is 1. So 5 minus 1 is 4. So there are, out of 10, 4 spectral lines will fall into Lyman. Similarly, how many spectral lines will fall into Balmer? N2 is 5 minus ground state of Balmer is 2. So 5 minus 2 is 3. Similarly, how many will fall into Pasteur? N2, that is 5 minus ground state of Pasteur is 3. So 5 minus 3 is 2. Similarly, bracket and fund you can calculate on your own. These sort of questions are asked. Okay, so have a proper eye on this sort of a question. Am I clear? Am I clear, people? Am I clear? Am I clear? Now, from the quantum numbers, you would have seen those questions. Which of the following quantum numbers are correct? Which of the following quantum number is not possible? Which of the following set of quantum numbers is possible? Which of the following set of quantum numbers is not possible? I believe you would have seen them. You would have seen those questions, right? And to solve those questions, there is just one thing which you have to remember. There is just one thing which you have to remember. My dear students, your first quantum number is your principal quantum number, which is represented with n. Okay, principal quantum number. Your second quantum number is your azimuthal quantum number, L. And the value of L is from 0 to n minus 1. Just remember it directly. 0 to n minus 1. Okay. Similarly, magnetic quantum number, M. Its value is from minus L to plus L. Minus L to plus L. And the last quantum number, spin quantum number, it can have value either 1 by 2 or minus 1. These are just the 4 things which you have to remember, and you are done. N is your principal quantum number, right? L is your azimuthal quantum number whose value is from 0 to n minus 1. M is the magnetic quantum number minus L to plus L. S is the spin quantum number whose value can be either plus 1 by 2 or minus 1 by 2. Now understand one thing. For example, here I am writing some sets of quantum numbers. Here I am writing some sets of quantum numbers. And you have to check which set of quantum number is correct and which set of quantum number is incorrect. For example, n value is equal to 5. L value I'm giving you 5. L is 4. And this is plus 1 by 2. Tell me whether this set of quantum number is correct or not. Second, this is 5. This is 4. This is, for example, minus 5. This is minus 1 by 2. The third one. This is 5. This is 4. This is minus 4. This is 0. The last one. This is 5. This is 4. This is, for example, minus 3. This is, for example, minus 1 by 2. Now tell me which all set of quantum numbers is wrong and which all are right. Tell me quickly. I want to know in the chats quick, people. Everyone means everyone. First of all, you have to check one by one. N is equal to 5 here. L is equal to 5. What are the possible values of L? 0 to n minus 1. So 0 to n is 5. So 0 to 5 minus 1. 5 minus 1 is 4. So L can be 0 to 4. So it can be 0, it can be 1, 2, 3, and 4. It cannot be 5. It cannot be 5. So this is incorrect. This is incorrect. Number 1. Number 2. N is 5. Okay. L, if n is 5, L will be 0, 1, 2, 3, 4. 4, that's correct. M is from minus L to plus L. What is L? L is 4. L is 4. So M will be from minus 4 to plus 4. Minus 4 to plus 4. That means minus 4, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, plus 4. What is this value that's given to me? That's minus 5. Minus 5 does not come in this. This is incorrect. This also incorrect. Okay, this also incorrect. Now, look at the next one. If you look at the next one, here the spin is 0. Spin can have only 2 values, either plus 1 by 2 or minus 1 by 2. Right? Spin Either plus 1 by 2 or minus 1 by 2. But here spin is 0. So this is also incorrect. Right? Look at the last one. 5. Okay. 4. Correct. Minus 3 comes in this. Right? Minus 1 by 2. Correct. So this is the correct set of quantum numbers that's given to us. Okay. There was a question asked in your JEE Mains examination from this as well. The question was like this. And I believe you can easily solve it. Write the correct set of quantum numbers for the last electron of rubidium. Last electron of rubidium. Now you might be thinking, how do we deal with such kind of the question? Think over it. Tell me. Think over it. Tell me. Think over it, people. I'm looking at your chats. I want to know the answer. Everyone. Everyone. See guys, first of all, there is only one thing that should strike your mind. What is that? Rubidium comes in which group? Lithium, sodium, potassium, rubidium, cesium, right? If I talk about lithium, sodium, potassium, rubidium, and cesium. Okay. Now tell me one thing. What is the outermost configuration of lithium? That is 2s1. Sodium will be 3s1. This will be 4s1. This will be 5s1. This is the outermost configuration of rubidium. This is the outermost configuration of rubidium. So the last electron is in 5s. The last electron is in 5s. The last electron is in 5s. So write the quantum numbers. What is the shell number? Shell number is 5. N value is 5. S subshell. The value of L for S subshell will be 0. The value of L for S subshell will be 0. Right? M. M is from minus L to plus L. Minus 0 to plus 0. That means 0. S can be either plus 1 by 2 or minus 1 by 2. Okay? So this is the correct set of the quantum numbers for the last electron of rubidium. Am I clear? Am I clear, people? Everyone wants in the chats? Quickly. Am I clear? I believe so. Perfectly done, guys. Perfectly done. There is one more small concept. What is that? That is your orbital angular momentum. How do you calculate the orbital angular momentum? One formula and you are done. Orbital angular momentum is nothing but under root of L into L plus 1 into h upon 2 pi. This is the formula. Orbital angular momentum is equal to under root of L into L plus 1 into h upon 2 pi. Now, first thing. Remember, for S subshell, the value of L is 0. For P subshell, the value of L is 1. For D subshell, the value of L is 2. For F subshell, the value of L is 3. Right? These are the L values. Which you should know first of all. Now, my dear students, for example, I'm giving you the question. You have got 2S subshell. You have got 3P subshell. You have got 4D subshell. Right? I'm asking you to calculate the orbital angular momentum in all of these. Tell me one thing. What is the orbital angular momentum in the first case? Since you have got S subshell. In case of S subshell, the value of L is? In case of S subshell, the value of L is 0. Right? So under root of 0 into something, that will be 0 only. Perfect. In case of P subshell, first of all, you have got nothing to do with N value. Right? Tell me, what is the L value for P? For P, L value is 1. So orbital angular momentum will be equal to under root of L into L plus 1 h upon 2 pi. So it's going to be root of 2. It's going to be root of 2 into h upon 2 pi. Or you can say it's nothing but h upon root 2 pi. This is the orbital angular momentum. Look at the next one. 4D, SPD. 4D, L value is 2. Orbital angular momentum is equal to under root of L into L plus 1 into h upon 2 pi. So 2 plus 1 is 3, 3 2s are 6. Root of 6 into h upon 2 pi. This is the orbital angular momentum. So this is how you calculate the orbital angular momentums when your subshells are given. Is this clear, people? Everyone in the chats once? Everyone once in the chats, if this is clear to everyone? Yes or no? Yeah? Done. And if this is done, guys, if this is done, there is one more concept which is frequently touched, frequently asked. That is calculation of nodes. Calculation of nodes. Important concept, frequently touched, frequently asked. My dear students, how do we calculate the total number of nodes first of all? Total number of nodes, the formula is n minus 1. Total number of nodes, the formula is n minus 1. Okay? The formula is n minus 1. Now, nodes are of two types. Now, nodes are of two types. One is called as spherical or radial node. Spherical or radial node. One is called as angular node. Spherical or radial node. One is called as angular node. The formula to calculate spherical or radial nodes, that is n minus L minus 1. Okay. Formula to calculate angular nodes, that is the value of L. Just these three things you have to remember and you're sorted. You're done. You're done. See, guys, what I'll be doing. For example, the question is, in 3S, calculate the total number of nodes, radial nodes, angular nodes. For example, 4D, calculating total number of nodes, radial nodes, angular nodes. For example, 3P, calculate the total number of nodes, radial nodes, angular nodes. Now you tell me, what is the n value first of all here? N value is 3, right? For S subshell, the value of L is 0. So tell me, how many total number of nodes are there? Total number of nodes is equal to n minus 1. So 3 minus 1 is 2. Okay. Angular nodes is equal to L. L value is 0. Spherical nodes, n minus L minus 1. So 3 minus 0 minus 1. So 3 minus 1 is done. Done. Similarly, 4D. What is n? N value here is 4. In case of D, SPD, L value is 2. Okay. Now, total number of nodes will be equal to n minus 1. So 4 minus 1 is 3. Right? Angular nodes is equal to the value of L. That is 2. Spherical nodes will be equal to n minus L minus 1. N minus L minus 1. So 4 minus 2 minus 1. Value comes out to be 1. Perfect. Now in 3P, n value here is 3. L value is 1. Right? So total number of nodes will be n minus 1. So 3 minus 1 is 2. Right? Angular node is equal to the value of L. That is 1. So spherical nodes, when you calculate, that will be also 1. This is something which is frequently asked. Right? Okay. Am I clear with this? Am I clear, people? Am I clear, everyone? Everyone? Perfect. This is one more concept, my dear students, which is frequently asked. Psi versar and psi square versar. Or this is in your syllabus, this is only for 1s and 2s. 1s and 2s. Okay, 1s and 2s. Now, I'll directly give you the graphs. Just remember them directly. No need to go for the conceptual understanding and just remember them directly. So first of all, psi versus r and psi square versus r. Psi square versus r. For which orbital? For 1s. For 1s. Remember, for 1s, it will be like this. Similarly, this will be also similar. 1s, right? If they ask you about 2s, psi versus r and psi square versus r, or what? For 2s. For 2s. Remember, when it comes to psi versus r, it will be like this. Okay? If it comes to psi square versus r, it will be like this. Okay? And remember these 4 graphs, that's more than sufficient. Perfect? Am I clear, guys? Everyone in the chats once? So these many concepts are sufficient for today. Tomorrow at 8 p.m., one more session I'm taking, right? That is part 2 of it. I'll be discussing some more 12 to 14 concepts tomorrow. And in the third session, we'll be done with all these concepts. All right. Is every single thing clear? Perfect, guys. Do let me know in the comment section how you liked the session and whether you want similar, more sessions, right, in the upcoming days. Do let me know that in the comment section of this. All right? Chalo. Thermodynamics, every chapter will be included. Don't worry. Tomorrow there's one more session. Day after tomorrow there's one more session. So remember, I have told you 3 sessions I have scheduled for all of this. So don't worry. Everything will be done. Okay? Take care, guys. Take care.